Two basic types of programming languages are used to ultimately get a microprocessor-based system to perform a necessary task. Scripting languages do not result in customized machine language, so their commands have to be executed line by line using an interpreter program and associated libraries that have already been compiled. The term scripting comes from the origin of the language as a sequence of commands that might be typed into the shell or command line for the associated interpreter console. On the other hand, compiled languages are translated into a customized machine language program that is specialized to the execution of that program alone. Ultimately, the execution of all programs come down to instructions running on the processor. So the interpreter programs or library functions that perform the operations of a scripting language are typically written in a compiled language. It's just that the compilation of the general interpreter and libraries is carried out well before and independently of any scripting language program run by that interpreter. Examples of scripting languages include Python, R, MATLAB, Perl, and JavaScript. Python is probably the most generally used for a wide array of applications, and JavaScript is also quite widely used, most commonly for dynamic HTML on web pages. R is a bit more specialized toward performing data analysis, and Perl is also more specialized toward automating the processing of text. Examples of compiled languages include C and Fortran, where the latest versions of Fortran include object-oriented data and program control structures. C++ and C# are the object-oriented versions of C. Java is technically a compiled language in that its code is compiled to machine language. However, the machine on which the Java program runs is virtual and implemented by a common program that has been precompiled to run on many different processors and operating systems. The motivation for this architecture is to allow the same compiled Java program to run on any system that can run the virtual machine. The fact that a Java program doesn't actually run on the microprocessor hardware might put it in a gray area between scripting and compiled. That summarizes the technical differences between scripting and compiled languages, but what do these differences mean in practice? Generally speaking, we often don't need the customized fine level of control over the memory organization or processor function to get a program to do what is needed. Therefore, we can use either type of language to write programs that provide similar user-facing features. However, the two types of languages are likely to achieve the same features with very different uses of memory in the processor. Therefore, if you care about how the program uses the processor or memory, you might want to use a compiled language over a scripting language. Here we will be introducing programming principles using the R scripting language, because it is a common tool used for data analysis in the environmental science community. Therefore, that community has provided many powerful domain-specific libraries that use R for specialized analyses. Let's think a little more about why R is a reasonable choice for getting started. Scripting languages generally operate at a higher level, meaning they can generally accomplish more with fewer lines of code. Because programs and scripts tend to be fairly linear in nature, they are good for scientific workflow that follows a step-by-step process. Compiled languages are lower level in that the individual lines of code can accomplish more specific tasks with memory allocation in the processor. This allows them to be more customizable for optimization of specific tasks. Compiled languages also tend to allow for less linearly structured general-purpose workflows, so they are frequently the choice for programs for managing complex multitasking or event-based computing that depends on user input. For example, you are not likely to write a program like Microsoft Excel in a scripting language. We are focusing on automating data preparation and data analysis in this material, so the case study workflows will generally be linear, and a scripting language will give us the efficiency to accomplish more with less code. R is a good choice of scripting language not only due to its widespread use in the environmental science community, but also because it is relatively easy to install and use without extensive understanding of the underlying computing technology. That said, if you were to ask me if R is the ideal language to use for learning programming fundamentals, my gut reaction would be a resounding no. R's flexibility in data typing and variable scoping in particular allows you to shoot yourself in the foot so many different ways and create hard-to-find bugs. Therefore, anyone who knows anything about software engineering would never choose to use R as a serious general-purpose programming language. But when I think about it further, the care you have to take as a programmer to write robust R code might actually be good training in programming, because it will definitely train you to be more careful about being sure exactly how data structures are changing through your program. In the long run, it doesn't really matter which language you start with if you take the time to learn fundamental programming skills along the way. Learning those skills in any language will allow you to pick up a new language in the future much more easily than your first.